Okay, good afternoon, everyone. So for today, we'll continue our discussion of the module for last week or the study guide for last week. Medyo behind schedule na tayo, and I think we will just be able to finish the entirety of this module on Friday. So perhaps I will move the deadline for. Pero sinabit niyo na pala yung worksheet about this no, about this study guide. So probably I'll need to defer the submission of the next worksheet number 5, if I'm not mistaken, probably some days ahead, para masimulan nating ma-discuss yung study guide for week 5 sometime probably next week. So medyo adjust na lang tayo, because I don't want to rush things, because I guess this is the heart and soul of Math 101 and your foundation for your future major courses. So I want to consider as many examples, because this probably would be the first time that you will be seeing proofs or writing actual proofs in detail. So siguro pagtrabahuhan talaga natin itong buong chunk na to. Anyway, I opted to add actually 1 week nung nag-meeting kami about Math 101. I added 1 week dito sa methods of proof, kaya medyo kakaiba siya from last semester. Okay? All right, and as advised by some of your classmates, we stopped before discussing example 6 last week. So let's tackle example 6. So recall that we are still working on writing existence proofs, or proofs for theorems or propositions that claims the existence of a certain element of the domain, satisfying some properties. And there are several cases to it. And if you already read the work text, kina-classify niya yung mga statements according to what type of existential claim is being made in that particular statement. May title siya. Tapos meron siyang suggested way of proving these things. Now, it's a little bit too technical for me. I don't want to teach you based on these classifications, kasi I believe na once you truly understand what the statement means, and you understand at least intuitively what the ordering of the quantifiers mean, and what they really try to claim, alam niyo kung paano i-attack yung proof. So pardon me if I will not read the classifications in the work text, kasi anyway, we won't be testing you and say classify the following theorems according to the type of existential claim being made. So lagi lang naman ang statement ay prove the following statements. So you need to choose the most appropriate method of proof. And I guess you can more easily determine what the most appropriate approach in the proof if you truly understand what each statement means. And so doon tayo magbabase. Instead na isipin pa natin ano yung classification niya, ano yung formal translation niya, basahin na lang natin yung statement, and let's try to see what it is trying to say, and we can plan our proof accordingly. Okay, I hope that's fine. And let's see this leftover example 6. So here we are asked to consider a function f, x squared minus 2x minus 3, and we want to prove that there exists a real number c, such that c is between 0 and 3 inclusive, and f of c is equal to -1. So ang idea, meron tayong function f. Ipakita na may nag-exist na isang real number sa pagitan ni 0 at ni 3, such that f of c is equal to -1. So the claim here is very general. Ang sinasabi niya lang, may nag-exist na real number. So kailangan, if we will go by what we did last time, kailangan maghanap tayo ng real number c that can satisfy these two conditions. That number c is between 0 and 3, and f of c is equal to -1. So your one possible proof, okay, for this statement is to search for an explicit value of c. Maghanap tayo ng isang example, katulad ng ginawa natin last time. Being able to demonstrate that indeed merong isang real number c satisfying condition 1 and condition 2, then we're done. Okay? Now, method 1, maghanap ng value ni c. Okay, so gawa tayo ng preliminary analysis, right? So gusto natin maghanap ng number c such that f of c is equal to -1. But what is the function f? This f is the polynomial x squared, x squared minus 2x minus 3. Ito plug into c, so I will get c squared minus 2c minus 3 equals minus 1. And then we'll try to solve for c in this given equation. So we'll do c squared minus 2c minus 2 equals 0. And the quadratic function or quadratic polynomial on the left cannot be factored. So we will resort to the quadratic formula. C equals negative b plus or minus radical b squared minus 4ac. Ano yung minus 4ac? 4, 1, 2. So that would be plus 8 over 2a, right? So this will become 2 plus or minus root 12 all over 2. Then this would be what? 2 plus or minus 4 root 3 over 2. And then this would be 1 plus or minus, sorry, not 4, but just 2. Halata nyo ng hapon na kasi yung algebra skills ko ay kukonti na lang. So, okay. Here we go. So there are two numbers c that will satisfy the equation f of c equals negative 1. And they are namely 1 plus or minus root of 3. But that's just one condition given in the theorem. We want the number c to satisfy both this equation and this inequality. C should be between 0 and 3 inclusive. So we got two roots here and say, okay, yung isa sa kanya ay 1 plus root 3 and 1 minus root 3. But what can we say about 1 minus root 3? Or magka-qualify ba silang dalawa as the value of c claimed in the theorem? I guess you can deduce that, see, square root of 3 ay mas malaki sa square root ni 1. So definitely this guy is greater than 1. 1 minus something greater than 1 would be negative. So this guy will not qualify because it is a negative number. So we say, we can choose C to be 1 plus root 3 kasi ito ay between 0 and 3, right? Kasi ito naman ay less than 2. Kasi 1 point something lang siya. Or you can compare it to root 4. Mas maliit yung root 3 sa root 4. So ibig sabihin yung 1 plus root 3 ay mas maliit. So 1 plus root 4, which is equal to 3. So therefore, I'm sure that the number C we are looking for in the theorem is 1 plus root 3. Because when you can prove this statement by saying, the number 1 plus root 3 qualifies as the number C. We just need to argue that number 1 plus root 3 is a real number. Second, this is between 0 and 3, and that this satisfies the equation f of c equals negative 1. So basically, isusulat nyo lang formally itong ginawa nating preliminary analysis dito. And that would be fine as your proof for statement 6. However, hindi naman kailangan lagi na mag-provide tayo ng isang example. We can take advantage of other known facts in order to prove the existence. Kailangan magbigay tayo ng isang reason bakit kailangan may mag-exist na number na yon. And for this particular example, we will take advantage, or an alternative proof is to take advantage of the intermediate value theorem. Tandaan niyo pa ba yung IVT mula sa math? Saan niyo ba siya nakita? Math 36, I think? Tandaan niyo pa? Or you need a refresher about IVT? Okay, I see a couple of thumbs up. So, but for those who already forgot, ang IVT sinasabi niya lang, pag meron kang continuous function sa AB, sa interval AB, so continuous yung function, so ibig sabihin kaya ko siyang i-drawing without lifting my pen. So, posibleng ganito yung itsura niya. Okay? Na-drawing ko siya na hindi nililift yung pen ko. So, ito yung example ni y, f of x, and f is continuous. Now, kapag meron ka daw continuous function, then sa kahit anong number, sa pagitan ni f of a at ni f of b, so ito si f of a, tapos ito si f of b, pumili ka daw ng kahit anong number sa pagitan ni f of a at ni f of b. Say, halimbawa, gumamit ako ng number k. Hanap ako ng isang number sa pagitan ni f of a at ni f of b. As long as continuous yung function f sa interval ab, I can always find a number c between a and b na ang function value ay si k. Right? Basta si k na sa pagitan ni f of a at ni f of b. So kunwari ito si k. So ibig sabihin, kung hahanap ako ng number c, ng function value ay si k, that number will be this. That would be the value of c. Yun yung sinasabi ng intermediate value theorem. For any number in the intermediate between f of a and f of b, there will exist a number c on the interval such that f of c is equal to k. And actually, madali siyang tandaan graphically kasi nga, continuous yung function. So kaya ko siyang i-drawing without lifting my pen from A to B. So ibig sabihin, kahit anong number na madaan ko mula sa starting point at sa ending point, laging may element ng closed interval ng function value ay yung number k na yon. Okay? And let's see if we can apply this theorem. Perhaps this will apply. So number one, requirement of the IVT, f should be continuous. Right? So in this particular problem, our function f is a polynomial. It's a quadratic function, so it would be continuous everywhere, right? So that's how you got this statement here. It's continuous everywhere. And then sabi ng IVT, kaya niyang i-guarantee na kahit anong number sa pagitan ni f of a at ni f of b, laging may number c ng f of c ay equal dun sa number k na yon. So let's evaluate f of 0 kasi siya yung left endpoint tong interval kung saan tayo naghahanap ng c. So f of 0 turns out to be -3. F of 3 turns out to be 0. So that means for every number between -3 and 0, there is always an element of the interval 0, 3 whose function value is equal to that number. And luckily for us, ang number na hinahanapan natin ng pre-image ay si -1. -1 is between -3 and 0. So there will exist, surely, a number c on the open interval 0, 3 such that f of c is equal to -1. So here, we have proven the statement, the existence statement, without even bothering computing for that number c. Kasi ang mahalaga lang naman doon sa theorem, patunayan natin na may nag-exist. And by appealing to the intermediate value theorem, we were able to say, dapat may mag-exist because IVT is already proven to be true. And it is sufficient proof that there will exist a number c, even if we don't know, number one, what is that number c? Or actually, we don't even know how many there are. Ilan yung mga possible c's na magamit natin. So yeah, that's another alternative proof for existence theorems. We need not give an explicit example, but we can argue using previously proven theorems that the existence is a must. Okay? So yun yung mga options. Pero itong pangalawang method ay required na tandaan nyo pa yung mga results na pwedeng magamit. So that's the burden for the second type of quiz. All right? Okay, I think that's the last example of a basic existence theorem. So let's look at more complicated forms of existence. Okay. Let's look at example 9. For example 9, we want to prove that for every positive real number, a positive real number x, x plus 9 over x is greater than or equal to 6. So kailangan makahanap, ipakita natin na ito ay totoo for all real numbers. So this is a universally quantified statement. So ibig sabihin, sa kahit ano daw real number, dapat totoo tong inequality na to. So we need to find a way on how to get about this proof. Okay? Now, pwede nating dayain. Wait, isipin ko paano ito magandang discuss. Okay, maybe I'll present to you the proof later and I'll explain mamaya paano nakbuo yung proof na yon. But the idea here is this is universal. So in our proof, we should consider a generic value for x. We won't impose any condition on x aside from it being a positive real number. And we should come up with this inequality, right? So the idea is you can start with a a known truth or a known property of real numbers in order to come up with this inequality. And the proof here used a very nice trick, right? Okay, so kung makikita nyo ang claim ng theorem for all real number x or for every positive real number x. So dun sa proof, sinimulan niya sa pagkuha ng isang arbitrary positive real number x, imposing no definite condition on it aside from being a positive real number. Kasi once na magdagdag ka na ng assumption about little x, wala na, malulose mo na yung generality required by the theorem. Kasi dapat totoo siya sa kahit anong positive real number, no questions asked. So hanggang pagiging positive lang, yung pwede nating i-assume dun sa number x. And then, alam natin na kapag ka nag-square tayo ng kahit anong real number, laging non-negative yung sagot, right? So since x is a positive real number, x minus 3 is still a real number. And when we square any real number, in particular x minus 3, we get a non-negative value. So this is a known fact. Kaya lang isipin nyo, sir, bakit out of nowhere, yan yung gusto mong gawin? Bakit hindi x squared greater than or equal to 0? Bakit hindi po x minus 5 squared greater than or equal to 0? You will see later the beauty of starting with this particular inequality. But I hope you agree that this is true. All right? Alam na natin yan na totoo, no questions asked. All right? So if you will expand this guy, the left-hand side, we'll get x squared minus 6x plus 9 greater than or equal to 0. Nothing fancy about that. Special product lang in apply. Okay. And then remember the requirement. X is a positive real number. So since x is positive, I can divide both sides of the inequality without changing the inequality itself. So divide lang natin lahat ng terms by x. We get this guy. And then 0 divided by x is still 0. And since c is positive, meron tayong greater than or equal to pa rin doon. Right? And the division by x is fine because x is not equal to 0. And then this looks very familiar, very similar to the given inequality that we want to prove. All we need to do is to add 6 to both sides, and we'll get this one. And this is what we wanted to show. And that ends our proof. Okay. Now, sir, paano? Maganda yung proof, right? Kaya lang, paano ko nalaman na dito ako mag-start? Well, our usual trick we do is do a preliminary analysis. Okay. So, gawin natin yung preliminary analysis. So, ang gusto kong ipakita, we want to show that, what was that? X plus 9 over x is greater than or equal to 6. Tama nga ba? Okay, yeah. Okay. All right, so ito yung gusto ko ipakita. And then I want to get, in the preliminary analysis, I want to get an identity out of this this statement that I want to show. And usually I want to get that identity or that tautology coming from biconditional statements. Okay. Now, since x is greater than 0, so this is for all x greater than 0, right? Since x is a positive number, I can multiply both sides by x, and I still get a biconditional statement. So this inequality is equivalent to saying that x squared plus 9 is greater than or equal to 6x, right? Nag-multiply lang ako both sides ng non-negative, ng positive number x. So wala akong na-violate. I can go back and forth. I can go from here until here, or I can go from here until here. So biconditional yung ginagawa ko. So these two statements are equivalent, meaning I can interchange them with each other. Okay. And then I can again subtract 6x from both sides and get x squared minus 6x plus 9 greater than or equal to 0. And again, here I'm searching for a tautology. Okay. Now, at this current form, hindi obvious yung pagiging tautology niya. But once I factor the left-hand side, I'll get x minus 3 quantity squared greater than or equal to 0, which is obviously true, right? So it is an obvious tautology. or an obvious identity. And the good thing about this analysis is, we call it a preliminary analysis, ay pwede akong magsimula dito, which I can claim to be true kasi obvious na obvious siya by properties of the squares of any real number. I can go from here, use this arrow to get up here, use this arrow to get a little further up, and then use this arrow to come up with the inequality that I want. And if you will notice, this is exactly what was used in the proof, although that is a little bit in reverse, right? Di pala a little bit, in reverse siya talaga. So that's how we get the statement, or that's how we knew that we should start with this guy. The thing about preliminary analysis, they are just scratch work. They are some prior work or prior analysis, and they need not be part of the actual proof. Kaya dun sa proof, hindi na pinakita na ganito. Nagsimula na siya rito, which is obviously true, and then used detailed arguments to come up with this desired result. Okay? So kaya ngayon, kung magpo-prove kayo, pwede kayo mag-PA muna, mag-preliminary analysis, bago dumiretso dun sa actual proof. Okay? Is everything clear so far? Or masyado na ba tong elementary for you? Okay. Okay, nice. So I think the next two remarks provides us with fallacious proofs or wrong proofs. At tingnan natin kung bakit. Let's look at example 1 or proof attempt number 1. Let x equals 1. Then x plus 9 over x, after replacing all x's by 1, we get 1 plus 9 equals 10. And that is greater than 6. And halimbawa, i-claim ko to na end of proof. Tapos na yung proof. What is wrong about that proof? Any volunteer? Ano yung problema sa proof nito? Yes, Prince. Si Prince na laging first honors sa pag-volunteer. Yes, go ahead, Prince. Yan, habang nagta-type si Prince, sip muna tayo ng coffee or ready nyo na yung button nyo for the next question. Okay, sabi ni Prince, pinakita niya lang po na mag-exist siya sa 1, which is hindi po sapat dahil lang kailangang i-prove ay mag-work para sa lahat. Okay, perfect, Prince. Yeah, that's right. Because this particular statement says that the inequality is true when x is equal to 1. But that is very short from what is being claimed in the theorem. The theorem is claiming that for every positive real number x, totoo yung inequality. So hindi sapat. Nabigyan mo lang ako ng isang example, isang real number na totoo yung inequality para masabi na proven na siya. Right? So this proof by example is wrong. Kasi kapag universal yung statement, hindi na pwede yung proof by example. Kung saan ang sinabi ng theorem is there exists a positive real number such that x plus 9 over x is greater than or equal to 6, then pwede na itong proof kasi existence. Kaya lang universal yung statement na binigay sa taas. So thank you, Prince. That's why this is wrong. And ayoko na next year, pag nasa majors na kayo, merong magreklamo na teacher nyo na bakit yung estudyante mo ng 101 nagpo-prove by example kahit universal yung statement, alright? So pag nangyari talaga yun, hahantingin ko kayo guys. So manda kayo. So I don't wanna see anybody in this class doing it in your major courses, okay? Lalo na kung ako pa rin yung magiging prof nyo sa majors. So yeah. Okay, let's see the second proof, proof attempt. Okay, let's see. Yeah. So sabi rito, let x be a positive real number x, and suppose that this inequality is true. Then I multiply both sides by x, we get this, and then I subtract 6x from both sides. And so I end up with something true, and then voila, this is true now. Proven in theorem. Why is this wrong? Oh, yes, Keith Neal.
Kasi po sir, nag-start po siya dun sa kailangang i-prove po.
Okay, thank you. Perfect. Ang mali dito sa proof nito, nagsimula siya rito. Sinopose niya na totoo yung gusto nating i-prove. So basically, we're trying to use what we want to prove in order to prove that particular statement. Tama ba yung mga pinagsabi-sabi ko? But anyway, I hope you get the idea. Bawal mong gamitin na pang-prove yung gusto mong i-prove. It doesn't really make any sense. Para bang sinabi mo na papasa ako sa Math 101 kasi papasa ako. So that will not be sufficient enough, right? So kung makikita nyo, parang ginawa niya yung preliminary analysis pero pinresent niya in a forward manner. Hindi niya kinlaim ang pagiging if and only if, right? And aside from that, nakarating siya sa tautology, pero hindi naman ito yung gusto nating ipakita. Ang gusto nating ipakita ay ito. So at the end of our proof, we should be able to justify why this must be true. So basically, ito yung gusto kong makita sa dulo at hindi ito. Alright? Siguro, ginawa niyo pa nga ba ito nung high school? Kasi dati ginagawa namin to. So, talagang dito nag-start, tapos mag-multiply ka ng x. Or nakwento ko na nga ba ito? Nakwento ko na yata ito. Ulit-ulit si sir. But anyway, yeah. Ganito yung ginagawa. Oops. And then, okay. Tapos nilalagyan ng question mark dyan. Tapos sa dulo, x minus 3 squared greater than or equal to 0, check and approve. Okay? So I hope by now it is clear why this will not fly as a nice proof. Kasi pag sa proof sa math, nagsulat ka ng isang statement, either assumption siya, supposition siya, previously proven na siya, or established na siya to be true. So you cannot start with this in your proof because we don't know whether this is true or not. So kaya bawal yung proofs na to. So you better start with something that you know to be true and work your way backwards. Yun yung ginawa natin by preliminary analysis. Okay? So I hope that's clear. Okay. Let's try this example. Example 11. For all odd integers, a and b is also odd. So this is again a universal statement kasi ang claim ng theorem, pag binigyan tayo ng kahit anong odd integers a and b, yung product nila ay odd pa rin. So hindi pwedeng isabihin ko a equals 1, b equals 3, 1 times 3 is 3, which is odd, end of proof. Kasi pupunta siya dun sa klase ng fallacious proof number 1 kanina. Alright? But if you are dealing with statements like this, na generic yung elements ng domain na kinoconsider, kukuha ka ng generic na A and B, but you'll try to see ano yung distinguishing property ni A and B or nung elements ng domain. Tapos yun yung gagamitin ko pang prove na yung AB ay odd din. So do you guys remember what is the distinguishing characteristic of odd integers? Kasi doon ko kukunin si A and B. So I will start my proof by saying consider odd integers a and b. I think we adopted the double struct O as our symbol for the odd integers. Then what can I say about a and b? Ang alam ko lang generic odd integers sila. Pero kailangan ko ng isang distinguishing property that I can say about a and b para mapakita na yung product ay a and b. Remember, I want to show that a times b is odd. So kailangan makita ko ano yung itsura ni a times b. And the itsura of a and b depends on how a and b looks like, right? Alam lang natin, si a at b ay odd. So anyone? Ano yung characteristic ng odd integers that separates them from others? Yes, Neil Christian? Nakita ko tumas yung kamay mo.
Sir, ano ba
Or
sir?
binawi mo ba?
2n
Okay,
plus
go.
1 po. 2n plus 1 po sir. Masasabing add integer
Okay,
siya.
thank you.
Or
That's
n
correct.
is integer po.
All right, perfect. So nagiging odd ang isang integer kapag pwede natin siyang masulat as 2n plus 1, where n is an integer, right? Yan yung distinguishing characteristic nila. Pwede mo siyang isulat na 2 times an integer plus 1. And si B, ganun din. Kaya lang iba dapat yung integer na gamitin nyo kay B. Kasi hindi naman sinabi na si A and B dapat equal sa isa't isa. So to maintain the generality of our elements A and B, so si B, pagpalagay ko na 2m plus 1. Pero here, n and m are coming from the set of integers. Right? So, and then, kung makikita nyo, si A and B ay generic pa rin. This will work for any odd integer. Because any odd integer can be expressed as this sum. Right? Pero okay, hindi pwedeng parehas yung ibigay nyo na value or multiplier doon kay A and B. Kasi hindi natin alam for sure na equal silang dalawa. So we need to keep our arguments as generic as possible. Right? Okay, then we can note that, we can note that A times B can be written as 2n plus 1 times 2m plus 1, right? Substitution lang ng value ni A and B. Tapos, pag minultiply natin yan, double check nyo yung multiplication ko. So this would be plus 2n plus 2m plus 1. Ito yung expansion ng product. This is how AB looks like. But can we conclude that A times B is an odd integer? Medyo malapit na. Kasi may plus 1 na tayo. Yun yung hinahanap natin. So the only thing is this terms should be an even number. And true enough, look at their numerical coefficients. Lahat ay divisible by 2. So I can factor out the 2 out of the second expression. So the first to the third term in our expression. So we can have 2mn plus n plus m plus 1 sa labas, right? Which is of the form 2q plus 1, right? Where q is an integer. Therefore, we can say that AB is odd. And that ends the proof. Right? Kasi napakita natin si A times B ay kayang masulat as 2q plus 1, where q is the integer 2mn plus n plus m. So, yeah, sure tayo na si A times B ay odd, provided that A and B are odd. And since we consider generic elements A and B of the set of odd integers, so this is enough for the proof. All right? So you see the idea here. If you're dealing with a universally quantified statement, we need to find number one, either one, a statement that holds for every element of the domain, katulad nun sa example 9 kanina, na nagsimula tayo sa isang fact na alam natin totoo para sa lahat ng positive real number, which is x minus 3 squared greater than or equal to 0. Or the second approach is to find the distinguishing characteristic for those elements of the domain. Ang domain natin dito, odd integers. So we looked for a distinguishing characteristic for odd integers. Okay? At ginagawa natin yon to preserve the generality of our arguments. Okay? So I hope that's clear. Okay, now let's look at example 12. In example 12, mas generic yung gusto niya sabihin. It wants us to prove that for every integer n, generic na yun yung domain, the integer n squared plus n is even. Medyo may konti tayong problema rito if we want to apply the same approach we used before. Problema rito ay, dapat integer si n. Ano pa ba ang distinguishing characteristic ng mga integers? Wala tayong maisip na magandang expansion para sa mga integers, tama? Hindi katulad nung odd at saka even, pwede mo siyang isulat na 2n or 2n plus 1, right? Para sa even and odd respectively. So, yun yung problema. So pag kumuha tayo ng generic element n, hindi natin alam yung expansion niya. So mahihirapan tayong intindihin kung ano yung itsura ni n squared plus n. Kasi gusto natin si n squared plus n ay mapakita na 2 times q for some integer q. Kaya lang, we don't know how n looks like because n is quite generic. It's just an integer. So on its own or at its current form, we cannot write n in more details kasi integer lang yung assumption. So when these are the cases you are confronted with, baka naman pwede mong i-partition o hatiin yung mga integers into classes such that each of the classes will have some distinguishing characteristics. And number two, the union of the classes. So pag pinagsama-sama ko uli yung mga classes, dapat makuha ko yung set ng lahat ng integers. And you will notice that in this proof, hinati niya sa dalawang classes o dalawang proof. Una, kinonsider niya yung mga even. Oops. Tapos pangalawa, kinonsider niya yung mga odd. Kasi ang kagandahan sa pagiging odd at even, meron silang distinguishing characteristics or distinguishing expansions that will allow us to know how n squared plus n looks like. So pwedeng ganito, proof by cases. But make sure that all of your cases can account for all integers. Yung case 1 para sa lahat ng even, case 2 para sa lahat ng odd, and lahat ba ng integers na cover na natin with just these two cases? Yes. Kasi ang integer naman ay either odd or even. So that means mako-cover na natin lahat ng integers kapag na-prove na natin na si n squared plus n ay even, kung si n ay even o kaya mapa-add man siya. Okay? And that is what is being done in the rest of the proof. So let's read it quickly. So case 1, n is even. Dahil si n ay even, meron na tayong distinguishing characteristic for it. So we can say that n can be written as 2 times another integer k. And this is quite a generic even integer, right? Kasi si k ay arbitrary. So this expansion will work for any even integer. And if I will use n equals 2k in the expression n squared plus n, we will eventually get 4k squared plus 2k, from which we can factor out the 2. So definitely we'll have 2 times 2k squared plus k. And we note that this multiplier, 2k squared plus k, will be an integer whenever k is an integer. And so n squared plus n is twice an integer, which is the very definition of being even. And that ends case number 1. Na-prove na natin yung kalahati kasi na-cover na natin lahat ng even integers. What's left to be done would be case number 2. Paano naman yung mga odd? Kung odd siya, ibig sabihin, kaya ko siyang isulat na 2l plus 1. Right? So, pwede ko siyang gamitin para dun sa n squared plus n. Gamitin ko siya, simplify ko, simplify ko ulit. So, magiging 2l squared plus 4, 6 plus 2. And I can still factor out the 2 from this trinomial. Right? Ganito yung itsura niya. Pero again, the multiplier 2l squared plus 3l plus 1 is yet another integer. So therefore, n squared plus n is the product of 2 and another integer, which is again the very definition of being even. And so this ends our proof. Kasi nahati na natin siya sa dalawang cases. All right? Is that good? Okay. Let's see. Example, exercise 13. Prove that for every positive integer, n squared plus 4n plus 3 is not prime. Remember, magiging prime siya kapag meron siyang factors aside from 1 and itself. All right? Paano ko kaya ito ipuprove? Any idea? And this should be true for any positive integer. Yes. Paula Nicole? Hi, Paula. Ano mo na nickname?
Paula po.
Okay, hi, Paula. So, paano natin siya ipuprove?
Let n be positive integer. Then, pinactorize ko po yung n squared plus 4n plus 3. So, n squared plus 4n plus 3 is equals to n plus 1 times n plus 3.
Okay. Okay, that's great. The next.
Since it has factors other than 1 and itself, it is not a prime number po.
Alright. Okay, thank you, Paula. That's right. Ginawa ni Paula, tama. In-assume niya na si n ay positive integer lang. So kahit anong integer siya, kaya kong i-factor si n squared plus 4n as this guy. At dahil si n ay positive, yung n plus 1 hindi pwedeng maging 1. Right? Yung n plus 3 hindi rin pwedeng maging 1. Kasi si n ay positive integer na. Pag dinagdagan mo pa siya ng 3 o kaya dinagdagan mo siya ng 1, hindi na siya pwedeng maging equal kay 1. So ibig sabihin, pareha si n plus 1 at saka si n plus 3 ay hindi pwedeng maging equal kay 1. So that means we have found two other factors of n squared plus 4n plus 1 aside from 1 and n squared plus 4n plus 3 itself, right? And that proves yung pagiging prime ng n squared plus 4n plus 3. So you'll just need to write the English. So yun pala, sa problem set, pag ako, most likely ako yung mag-check ng proving problem. So aside from being technically correct, I'll be also looking at how you presented your ideas. So kailangan isulat nyo ng klaro at saka ng sunod-sunod yung statement, you arrange it nicely para bang nagko-convince kayo ng isang tao. So yung kagandahan ng pagkakasulat will be factored in grading. So kung perfect yung technical details, probably you'll get between 80 to 90%, pero yung remaining 20 to 10% ay manggagaling dun sa way you organize your thoughts. So kasi gusto natin hindi lang tayo marunong mag-compute at mag-prove para sa sarili natin. We want to communicate our results. So I want to start early with you guys. Ngayon pa lang 101, sanayin na natin na maganda yung pagkaka-present ng arguments natin. Okay? And that's the reason why we are going through every detail. Though hindi ko na sinusulat lahat kasi sinasabi ko naman siya. Pero pag kayo na yung nagpa-problem set, kailangan yung isulat lahat. Kasi wala naman kayo doon para sabihin kung ano yung gusto niyo sabihin on paper. So you need to write everything on paper. Alright? Kaya mas okay yung nagtuturo eh. Pwede ko na lang sabihin, hindi ko na kailangan isulat. Pero kayo, kailangan yung isulat kasi yun lang naman ang makikita ko sa problem sets niyo. Okay. Now, let's look at some more examples of existence theorems. Example 14. Prove that there exists a real number x such that for every y, this equation is true. Okay. Medyo i-dissect natin yung theorem. Gusto natin ipakita na may nag-exist na real number x. So medyo excited kayo kasi mukhang madali yung proof kasi existence lang naman. Existence ng isang real number x. So if you can demonstrate that a particular real number x satisfies the theorem, then tapos na. Okay? Pero ano yung condition that that particular real number x must satisfy? It should satisfy for every real number y. This equation is true. So medyo mabigat pa rin pala yung theorem kasi ang hinahanap natin ay isang number x na kapag sinamahan ko siya ng kahit anong real number y, dapat totoo tong equation na to. So my choice for x must hold or must apply for any real number y. Totoo siya dapat sa kahit anong piliin kong real number y. So in our proof, or if you do the preliminary analysis, kailangan si y i-leave natin as a generic real number. Ang hinahanap natin lamang ay si x. Okay, so we need to be a little bit careful about that. So sa prelim analysis, so we want to find an x such that xy minus 3x minus 3y plus 12 ay equal kay y. But y is a real number, a generic real number. So hindi ko pwedeng palitan si y ng kahit ano. Kasi si y ay generic real number. At yung hinahanap natin na x, dapat mag-hold siya sa kahit na anong random element ni R. Kaya sana maintindihan niyo kung bakit hindi ako pwedeng magbigay ng specific example kay y. Kasi dapat yung mahanap ko na x, mag-hold siya sa kahit na anong y. And so we have no choice about that, and let's just pray na yung masasolve natin na x ay independent kay y. Kasi dapat si x mag-hold sa kahit na anong y. Right? Let's see. So dahil naghahanap ako ng x, gusto ko sa left-hand side, matira lamang lahat ng may x's. So, ang gagawin ko, xy minus 3x, yung mga walang x, lipat kayo dun sa kanan. So, that would be what? 3y minus 12. Pero pwede kong i-factor yung 3y minus 12. Pero gawin ko na siya sa next line. And then the reason why I want only those with x's to be on the left-hand side ay para ma-factor ko yung x. Factor ko yung x, y minus 3, equals, factor ko rin yung 3 mula sa kanan. Okay, and then I can divide both sides by y minus 3. That will give us, wait, parang may mali. Hold on, dapat 4 yung makuha ko. Anong mali guys yun sa ginawa ko? Okay, sorry. 4y. Okay, thank you. Sabi ko sa inyo, wag niyong i-trust yung algebra ko. So, yeah. That should be 4. Tama na ba? Okay. Then divide both sides by y minus 3. So, x equals 4. But provided that y minus 3 is not equal to 0. Kasi hindi tayo pwede mag-divide by 0. So, there is something wrong if I divide both sides by y minus 3 and yet y minus 3 is equal to 0. Okay? So ngayon, nakakita tayo ng x na mag-hold para sa kahit anong y na hindi equal kay 3. Right? Kasi equivalent to saying that y must not be equal to 3. So, sure tayo na si x equals 4 mag-hold sa kahit anong y na hindi equal kay 3. So, ang problema natin, mag-hold pa rin ba yung x equals 4 kapag si y ay equal kay 3? Well, we can do a quick check here. If y is equal to 3, what will happen to this guy? This will become 0. This will become 0. So the left side is x times 0. The right side is 4 times 0. Both sides simplifies to 0. So we get a tautology 0 equals 0. So ibig sabihin, si x equals 4 pala, nag-hold pa rin kahit si y ay equal kay 3. Kasi tautology makukuha natin. So we can say, after a preliminary analysis, that x equals 4 will work for any real number y, be it equal to 3 or not equal to 3. And so I can work backwards and use the result of our preliminary analysis to write the actual proof. And you will see in the actual proof, pinakita niya lang, since existence lang naman ng x yung gusto mong ipakita ko, so bigay ko sa'yo, si x ay equal kay 4. Tapos i-plug in mo man yan dito, ang makukuha mo ay y. And that is enough proof, right? But again, sa pagsusulat ng proof involving an identity, lagi kayo mag-work sa isang side lamang. Huwag niyong sisimulan yung proof nyo na naka-equate kagad kay y, tapos lalagyan nyo ng question mark, tapos magpa-plug in kayo ng x equals 4, equals y, lalagyan nyo ng question mark, tapos eventually papakita nyo na y equals y. Hindi ko to tatanggapin as a formal proof. Alright? Because in math, we don't have symbols like equality with a question mark or a check above. So hindi natin siya tatanggapin in our convention. And again, kung i-remove mo yan, then tas nakita ko sa proof, sinimulan mo kaagad dito. So I will read that as if you are using the exact equation that I want you to prove as your proof, which is technically wrong. Right? So kaya ang gagawin nyo, pag nagpo-prove ng equations or identities, mag-start kayo sa isang side lamang. Kasi pakita nyo na magpa-follow yung right-hand side. So dito, nagsimula ako sa left. So gusto ko, at the end of the day, I want to get the right-hand side. And true enough, simula ako sa left, plug in ako ng x equals 4, napakita ko equals siya kay y. And that ends the proof because we have found an x that will work for any real number 1. All right. Is that okay? Okay, let me see what's next. Medyo time na nga eh. So, is it okay if I borrow 10 more minutes? If you need to go, you can. para lang sumabay tayo dun sa kabilang section, tapusin natin yung example 17. Okay, kasi iba namang form ito. Yung example 17, we want to prove that for every real number x, there exists a real number y such that x squared plus y plus 2x equals x. So kung isusulat natin to formally, nakita natin yung form na to last time or nakita nyo sa lab classes, no? For every real number x, so for all x in R, there exists a real number y in R. Oh, sorry, a real number y. So ito yung itsura ng quantifiers. May dalawang quantifiers involved. Nauna yung for all, sumunod yung there exists. So ibig sabihin, gusto nating makahanap sa kahit anong given real number x. So magbigay muna kayo ng generic real number x kasi yun sabi ng theorem. Kahit ano pang real number x yan, may mag-exist na y such that this equation is true. So what we need to do is, we will be given an arbitrary real number x. Dapat hanapan natin siya ng y. Ang kagandahan nito, which is ang kaibahan rin niya, mula dun sa kabilang, dun sa previous example natin, yung choice natin ng y ay hindi kailangang mag-work sa lahat ng x's. Kasi ang sabi dito sa pagkakastate ng theorem, sa kahit na anong x, may mag-exist na y. So, ibig sabihin niya, pag binigyan tayo ng x, dapat may mahanap tayo na y. So the idea is this y need not work for all real numbers x. Ang kailangan nating ipakita ay pag nabigyan tayo ng x, dapat makapagbigay tayo ng y. Right? That will work for that specific given x. So that's why this y might be dependent on x. Pwedeng yung choice of y natin nakadepende dun sa given y in the beginning. Because ang usapan lang naman, ang challenge lang sa atin, pag binigyan tayo ng real number x, humanap tayo ng y na makakasatisfy nung equation na to para sa kahit anong given x. So pag nagbigay ako ng arbitrary x, kailangan makasolve ako ng y, and that y might be dependent on the given value of x. And that's what we'll try to do in our preliminary analysis. So again, our goal, we want to find, oops, na-avoid ko nga pala yung abbreviation na yun. So we want to find, so given an x, given an arbitrary x, we want to find y, which might depend on x, such that x squared y plus 2x equals x. So ito yung gagawin natin sa PA, right? Manap na tayo ng y sa bawat x. So yung y pwedeng mag-depend kay x. So what can I do here? Well, I'm looking for y. So gusto ko y lang yung matira sa, yung mga may y lang yung matira sa kaliwa. So lipat ko lahat ng walang y sa kanan. So we'll get a negative x here. And then I can divide both sides by what? By x squared. But here, provided that x squared, yung pinang-divide natin ay hindi pwedeng maging equal kay 0. And then so that means y must be negative 1 over x squared. Negative 1 over x. And again, this will suffice as our choice for y. Kasi ang idea lang naman, pag binigyan tayo ng x, dapat may maibigay tayo na y. So limbawa, binigyan ko kayo x equals 2. Oh, by this formula, yung y ay negative 1/2. Pag binigyan ko kayo ng negative 1/2, yung y na work para sa kanya ay positive 2. So ibig sabihin, yung challenge ay x, yung respond natin ay y. And that's possible because we don't want y to necessarily hold for any x. Ang usapan, yung pagkakastate ng theorem, sa bawat x may mapakita tayo na y. And we have done that here in our prelim analysis. Napakita na natin na kapag binigyan ko kayo ng x, basta si x wag maging equal kay 0, yung response ay negative 1 over x. Now, kapag ka si x ay 0, ano kaya yung respond? Kasi yun yung case na wala tayo eh. Kung si x ay 0, ano yung respond na y? Anyone? Kasi yun na lang yung butas sa proof natin, no? Kasi napakita na natin na hanggang si x ay hindi nagsi-0, pwede natin gamitin y si negative 1 over x. Pero kapag ka si x ay 0, ano kaya yung pwede natin gawin? Kasi si x real number, so sakop siya ng theorem. So ano kaya yung y na mag-work para kay x equals 0? Volunteers? Oh yes, Crizel?
Any y po, pwede po sa 0.
Any y? Bakit mo nasabi na any y?
Since magiging 0 lang po siya from ito po sa simula, sa x quadrat plus 2x is equals to x. So if x equals to 0 po, so magiging 0 equals 0 po, which is true naman po. So any y po, pwede.
Okay, thank you, Crizel. That's perfect. Because if x is equal to 0, kasi isa na lang, yung hindi natin nako-cover, si x equals 0 na lang. I-plug in nyo si x equals 0 dun sa equation. Tapos makikita nyo, 0 equals 0, tautology. Right? So, ibig sabihin, true ito. Kasi totoo lagi yung equation na nakuha natin or isa siyang tautology. Nalala ko kasi mnemonic ko dati nung undergrad sa tautology ay totoo lagi. Parang tautology. Anyway, fun with words. But yeah, any number y will hold for x equals 0. So bigyan niyo yung favorite number niyo, x equals 17. O bigyan niyo yung last 5 digits ng student number niyo. Mag-work siya kapag si x ay equal kay 0. So yeah, so in our preliminary analysis, we already found the y. Kapag si x ay hindi 0, piliin mo negative 1 over x. Kapag si x ay 0, kahit anong y will work because it ended up with a tautology. So, kung susulat niyo yung formal proof, ganito yung magiging itsura niyo. Okay? And kindly read the formal proof. Wala na tayong time para basahin siya, pero nagawa na natin yung hard work. Yung mahirap na parte ng pagsusulat ng proof is the prelim analysis itself and devising an approach for the proof. And it's just formality to write the actual proof. But you already have them in the work text, so kindly read on them. Kasanayin nyo na rin kung paano magsulat ng proof. Okay. Let me see. Okay. Maybe I'll stop here. Halos kasabay lang naman natin yung kabilang section. So, any questions, guys? Parang ang bilis ng isang oras, no? Siguro pag nag-enjoy ay talaga mabilis yung pagtakbo ng oras. Yes, Keith, do you have a question?
Sir, kapag nag-submit po ba kami ng requirement, need pa po ba ipakita yung preliminary analysis?
Oh, good question. Pagkang instruction ay prove the following, hindi nyo kailangang ipakita yung preliminary analysis. So parang magugulantang na lang kami na, parang ang tali-talino ng proof kasi out of nowhere nalaman niya na yung y ay dapat negative 1 over x. So makikita niyo dun sa proof, without prelim analysis, sinabi niyo lang, kapag si x ay hindi 0, piliin mong y is negative 1 over x. Di ba mukhang matalino? Kasi out of nowhere, alam mo na si y ay equal kay negative 1 over x. Tapos ipapakita niya lang na, by verification, pag sinubstitute ko siya dito, makukuha ko ay equal kay x. So that's fine because we didn't ask you to show the preliminary analysis. All we wanted is a proof. And the PA is not part of the proof. So kaya hindi nyo na siya kailangang ipakita. Right? Pero may advantage din yung pagpapakita ng prelim analysis. Kasi para sa akin, kung ako yung mag-check, pinakita mo yung prelim analysis, nagkamali ka ng konti, merong isang line na nagkamali ka ng algebra, tapos yung nakuha mo sa PA, yun yung ginamit mo sa actual proof. Kung hindi ko nakita yung PA, hindi ko alam kung saan ka nagkamali dun sa actual proof. So I cannot give you as much partial credit that you can get if I know where you got the mistake in your PA. Kasi kung nakita ko yung PA, sobrang liit na algebraic mistake lang yung dahilan kung bakit mali yung ginamit niya sa proof. So I might give you 95% or 90% of the total score because I know where you messed up on that tiny detail in the PA. In contrast, pag hindi mo pinakita yung PA, tapos totally wrong, out of nowhere, may equation na hindi naman totoo pero ginamit mo, mag-iisip ako, bakit niya ginamit to pero false naman siya? So I might not give you as much partial credit as I would have given you if I have known what the PA is or where you messed up in the PA. So yun yung mga kailangan yung timbangin. So may partial credits or mas malaking chance na makakuha ng mas malaking partial credit pagka nakita ko yung PA. Kasi matitrace ko kung saan kayo nagkamali. Pag proof lang yung pinakita nyo, hindi na ako mag-e-effort na hanapin kung saan yung mali. Kasi ang usapan lang naman ay ipakita yung proof. Eh sa proof may ginamit kayo na hindi naman tautology, so invalid na yung proof. So you might not get as high a partial credit as possible in contrast if I have known what your PA was. Okay? So yun yung advantage ng my PA. So any other questions? I hope it's okay if you're lagging behind the schedule. So kung sinusundan niyo yung study guide, medyo mauuna kayo. But I really want to talk about things rather than just read and browse through them. Kasi nga, ito yung foundation. Mahalaga to para sa mga susunod niyong courses. At mahalaga rin siya sa second half ng Math 101. So I don't care na medyo ma-delay tayo ng konti basta ma-cover natin in details yung bawat detalye ng topic. Okay? Any other concerns? Overtime na talaga. So if there are none, then thank you guys for coming today. I hope you enjoy the rest of the evening. Find some rest. And then let's see each other again on Friday. Bye, everyone.
Bye, sir. Thank you po.
All right.
Bye po, sir.
So by the way, yung mga nag-recite pala, yung mga nag-recite, pa-comment ulit. Thank you.